Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Carl Carlson.
Hey, Carl. Hey, I understand. I sent you a question because I knew you would handle it way better than I could. And it was, and I know you had a chance to respond, but so today's a listener question on FMEA of sorts. I think it was related to.
Yes, it's a great question from a listener. I sometimes say reader, but this is a listener of podcasts, longtime listener, and it had to do with the predicted cost savings of Design FMEA. And he had some ideas about a model and some questions, and it was a really well thought out, a fairly lengthy email. And I'd love to talk about it with you.
Yeah, sure. No, I'm always into the that we don't do stuff just because. Although some people do because it's on the checklist. So they just kind of get in the room, chat for a while, have a pizza, and then call it an FMEA. That's that terribly useful.
Not terribly useful. I have been challenged, I'll say that, use that word, for years on the subject of the value of Design FMEA, particularly can Design FMEA predict warranty costs and be valuable in terms of warranty models and that type of thing. And I have some fairly thought out opinions on the subject that are open for discussion. In other words, it's a work in progress. I've thought through it, but I'm always open to ideas on this because model-based engineering is really a trend, and model-based FMEA is a trend. And so we have to understand what that is and what it isn't and what the assumptions are. But I want to, in this podcast, I'd love to talk with you about whether or not it's possible to predict warranty, specifically with the ideas that the gentleman has. And so let me just summarize his what he said in his email. He talked about not an entirely new design, but it's a design that exists, and then you make changes to it.
Right.
And so there might be an FMEA in record, and then you're doing most of the work on the FMEA for analyzing the changes. And that's a fairly common scenario.
Right.
And so what he's looking at is he identifies three categories. You have the the failure modes that are unaffected by the change. And so you have the carryover or the on-the-shelf portions of the design that aren't changed. You have some known reliability issues. Usually if you have a fielded item,
right.
There's going to be some issues. And then the important one is the third category, which is the new components and features, which would be the primary subject of the FMEA. And so he's thinking that if you understand these three elements and you weight them, WEIGHT, that the third element of the newness would have more weight. And of course, I would agree with that. There's where the risk is the things that are new. He thinks that you can estimate the warranty cost based on knowing what failure modes happen in the field, and you'll have some degree of empirical data on field failure rate. Then you look at what's new, and you predict in some way the cost of repair and replacement based on the severity and occurrence rankings, and also looking at lost business. So I've just summarized his ideas that he has. And then if you add up all this within the scope of the FMEA, you will get some type of warranty prediction. And then he said, what do we think? So now it comes down to what do we think? And I've got some thoughts. If you go ahead and jump in if you want to.
Yeah, I remember reading that and thinking, to me, and this might be my statistics background going, is in my experience is I ran into a team, and they weren't trying to model warranty expenses. They were trying to decide, have we found enough? And did we make the right decision to ship this product at this stage, knowing what we knew at that time, versus if we would have delayed a month, would it have made a difference? You know, did we rush too quick to market, or did we get it right? And so they hired a person to go through their fracas system. So it wasn't exactly FMEA. It was things that they knew and recorded were anomalies or issues or problems. And like any product development process, like an FMEA, you don't address all of them. We don't. Some are deemed unnecessary. Some are deemed, insignificant and no severity and all those other reasons that we triage.
You'd waste a huge amount of time if you tried to address everything.
Right. So this poor intern, she had, 1,000 plus records in the fracas system for this design. And the design had been in the field for a couple of years. And they had, the warranty returns and in the data back from the field. And her job was to link up what did they see in the field and how did they correspond to what we knew about but did not fix. Right? So if an FMEA is done well, it should correlate with your fracas system, the stuff that you are finding. Now, there will be some proportion. I'm going to circle back to the FMEA model, this idea in a second. But here's the stuff that in the team, in their testing, in their prototyping, in their design simulations, in all of the process, and they had a pretty robust fracas system. And they said, all right, we chose to cut the line here. And it turned out that the top 10 field problems that they had were in the next 12 issues. If they would have fixed those, they would have saved like $4 million on warranty, which would have paid for the extra month for this particular project, kind of thing. And if they figured if they would have knocked off the next 50 items on the list, it would have saved them tens of millions of dollars and over the life of the product, kind of thing. But at the heat of the moment, you knocked out all the big things. You knocked out all the, this doesn't work and the green light doesn't come on and it's functional and it does this and does that and does that. But it was all those things that you saw that one person saw it when the device was being tested at 80 degrees C and they wrote it down. It was a problem here. And the powers that be said, well, we're rated to 40 degrees C. That's a good enough margin. We're not going to deal with it. But it spoke to the robustness of the product, for example. And so they didn't address it. And at the time, it's a rational decision. It's the one that the device caught on fire at room temperature when you turned it on, that one had to be fixed. So back to the FMEA part. If there's a strong correlation of the top issues that were not resolved, ended up being your field problems, then you're onto something. But if that is a tenuous relationship, if what you see in the field is a complete surprise from what your FMEA indicated, then you need to fix the process before you can use it as a weighting factor to predict anything. If it's got a strong correlation and it corresponds to what you actually see in the field, you're onto something. But if it doesn't, then try something else.
Okay, you really covered quite a bit of scope there, and a lot of you brought up some interesting things. There's the issue of, does the FME correlate to the field? That's an important topic,
right? And that's a different process than doing an FMEA to improve the design. And that's my other big issue with it is that are you doing this to improve the design, to prioritize what you want to work on and identify things that you should address or identify or explore more or experiment with? Or are you using this tool as a prediction model, which is not really what it's made, in my opinion, is not really what it's made for?
Well, I'm going to have to agree with you on that. I've been saying for a lot of my career that the purpose of FMEA is to improve the design. I mean, that's not for me. That's like most everybody understands that. And the purpose, and now let's get down to the purpose of the occurrence rating, because this is what it comes down to, is the value and application of the occurrence rating. Some people, and I'll even name names in the podcast, but Some people want to use the occurrence rating to predict the failure rate. You can do that if your occurrence rating is based on field data and if you haven't made any design changes to the item. But in most cases, when you do a Design FMEA, you're doing the Design FMEA because you've made changes. Right. There's a different environment, there's different technology, there's different materials, there are changes. And so the field failure rate that you can pull from Fracas or wherever you get the data from is not going to be directly applicable. It'll be somewhat applicable. Right. And so we have to recognize that, because a lot of people plug in and put failure rate information into the occurrence rating scale, and they say, okay, now that becomes a failure rate. And so we have a new design, and therefore we predict the failure rate of the new design based on the FMEA. That is not good.
Not good.
That does not work.
And I have never seen anybody prove that works, or even try to prove it works, because it's, and I understand some people look at, we're going to put a lot of time into this FMEA. Let's get as much out of it as we can. And here's all these occurrence rating things that, if we say, all right, here's the failure mechanisms we did not eliminate from the design, they're likely still going to occur. Let's tally them up and then we're done. Well, no, I don't think so.
Well, and now some software packages try to do this.
Oh, I know. They love numbers and adding them up.
The FMEA software package directly communicates to the life data analysis software package, and they start plugging the occurrence ratings from the FMEA into the system reliability model. So you have reliability numbers suddenly you get from the FMEA. That is not a good practice, in my opinion, because that's not the purpose of the FMEA.
When I run into it when I'm facilitating an FMEA, it says, "Oh, do we need real numbers for this?" I'm like, no. Use your engineering judgment. Is this going to fail more or less than that thing? And is it going to be more serious failure or not serious failure? It's a relative ranking based on your engineering judgment. Yeah, if you've got some history and you got some background information, you know about these things. Well, one, go fix it. If it's important, go fix it. You don't need to do an FMEA to sort out that, burning the house down is a bad thing. Go fix it. But
exactly.
There was way too much. If you spend the whole day tracking down failure rates, you've kind of missed the point of an FMEA. That's been my opinion. And some
people still do.
I know.
Crazy. You and I are preaching, and other people are preaching, that the whole point of the FMEA is a relative analysis. It's a subjective analysis. Yep. You're doing it early in the product development process, particularly a Design FMEA, and you're using the occurrence rating and the severity rating to prioritize risk. You're not doing it to calculate reliability.
Right.
And once you get that understood, then you can, within the context of the occurrence rating, you do not want to be predicting reliability. And that's the problem that I'm having with the idea. And I really appreciate the idea. And there's a lot of good possibilities in the modeling that the listener has sent to us. And I'll talk about some of the positives. But the thing to be concerned about is you have to assume that you can get a failure rate from an occurrence rating in order to use that to predict the failure rate in the field for the new portions of the design, not for the currently fielded.
Yeah. I've seen people use, we've got 80% of our product is the same essentially, and we're updating this part and this part, or we're adding this feature, for example. And so 80% of the design is relatively new. They're not bleeding edge, not cutting edge, not complete unknowns. We're using this wonky new material that we've never experienced before. None of that. It's pretty standard. We're going to do a cost reduction on a product or something like that. It's much, much easier to ignore the FMEA, except for identifying failure modes that you need to learn more about. And that then sparks other testing or other simulation work and everything else to learn more about it, so you can get a reasonable estimate of it, whether you need to fix it or not. But I've seen plenty of people take that 80% of the fielded stuff. We have pretty good field data on that. Let's just use it. And then say the 20% is, it's similar components, it's similar technology of devices that we're doing and stuff like that. And we have a Pareto of 5 things that is being designed out of it. Maybe your FMEA is saying, we're going to design this, this, and this out. And so take your field data of the component you're replacing or the module you're replacing and say, well, those won't exist now because we just designed those out. I've seen that logic work much more directly without having to rely on the occurrence rating.
Right. And there's so much, and we could talk forever on the subject of prediction, and what assumptions go into predictions, what models work and don't work, and that type of thing. And so let's just, in terms of this particular question, let's just state that the occurrence rating is not designed to generate a reliability number.
Yeah.
You can use failure information from the field as an input, but then you have to take into account the degree of change, how it's changed, and you have to consult the subject matter experts that are on the team, as you said, Fred, as to say which one's worse than other ones. You're looking for a relative ranking.
Right.
That's the whole purpose of the occurrence rating. And when we try to use it for something else, it always runs into trouble.
Yeah. And it's trouble in that it's not accurate in one part. And the other part is it derails the intent of why you're doing the FMEA, in my opinion.
2 very good summaries, and they're different. You're right. That one is it's not what you're supposed to do, and 2 is you're not going to get the information anyway if you try to use it.
Right.
The problem is the what would you call this? It's kind of like if you have a hole and then you camouflage it, you don't see it.
Yeah.
People put numbers in things without the right justification, and those numbers take on a life of their own. I've seen this in the software packages that I'm talking about.
Oh, yeah.
People will do an FMEA, and then you can intuit in some way what the ranking is of the occurrence and say, okay, that's associated with this kind of failure rate. And then people will say, yeah, I know it's not very accurate, but at least it's a number. And then suddenly it becomes the failure rate because people forget all the context.
Yep.
And then it takes a life of its own.
Until it's proved wrong. And, luckily of 1,000 components in a device, you really only have to deal with 10 of them. It's
right.
So most of the stuff is just not ever challenged or doesn't come up as, and I rarely ever see an organization these days that does 2 component failure analysis in all their field data. They say, oh, the motherboard failed or the power supply failed. And they, toss it and without detailing it out. One of the general managers I worked for years and years and years ago, if you brought him a proposal or you made a statement or you're running an experiment or whatever, it was always show me the data. And this was before Moneyball was a movie. Show me the data.
Show me the money, show me the data.
Yeah. And he would, and he wasn't, he had a technical background, but that wasn't his strong point. But he said, if you can't answer that question and show me how evidence supports your position, then I'm not going to, I have the perfect opinion then of ignoring that input. It was kind of the way he phrased it.
Well, and I said I would acknowledge some of the rightness about the question. First of all, it's good to try to create a model. And it's equally good to know what the assumptions are that go into the model, because no models are perfect.
Yeah.
And the other thing I wanted to mention is that it's good to highlight the known reliability issues. It's good to highlight the field data, and that can all be input to an FMEA. And it's good to realize that the priority for the FMEA is the new components and features.
Yeah.
And it's also good that the gentleman noted that the language of business is money. And so he said, well, we got to convert it into money. The problem is many have tried. It can't really be done, in my opinion. If you're doing FMEAs for the right reason, you're not going to get an immediate dollars output on an immediate basis. You're not going to be able to predict the warranty for the portions that are new features. To me, this is like HALT. where you're going to identify the failure mechanisms and you're going to design them out, take care of them, but then trying to use HALT to predict reliability is a completely different subject.
Yeah, no, and yeah, I'd say go to a reliability block diagram. Keep it simple. You know the majority of your product from your field data. If you're not solving those issues and you're focusing on the new part, well, then use the block diagram to say, what do we know and don't know? Are these estimates good enough? And then there's many other methods out there to help you understand what's the reliability of that new part of your design. FMEA is a stepping stone in that process to understand, well, what are the failure modes and mechanisms that we care about, that we need to go understand? It's way too many times in an FMEA, we get a relative ranking and we really don't know. So we make it a little bit higher. And then the action, at least the action I often recommend is, well, let's go understand, is this really a problem or not? Let's go run a test that says, this mechanism really happen? You know?
And you summarized it well. There's actually and you've pointed out, and you're correct, we want to keep the quote types, unquote, of FMEA to a minimum. You don't want to have 15 different types of FMEA.
Yeah.
So, but there is a paper that was written by Dr. Pecht and some others at University of Maryland on what's called FMEA, which is Failure Mode Mechanism and Effects Analysis. And the entire purpose was to prioritize which failure mechanisms are the ones that are most influencing this design and the failures of the design, so that you can then go model them and use those mechanisms and basically use the mechanisms to improve the design. It's a nice worksheet. It's a nice analysis. That has value, understanding the mechanisms, like you were saying. What doesn't have value is trying to use the FMEA to predict reliability. And I agree with you that it's a stepping stone.
Yeah.
It can be input to the actual system reliability models that will result in some type of prediction.
Well said.
So this becomes then this podcast, and I'll summarize it and write back to the writer. And I just want to say, if you're a listener and if you want to weigh into this, because we'll give it a week or so after the podcast is published. If you have comments, please get back to us, because we'll take those into account and try to summarize this for the listener. And I want to encourage, if anybody has questions or comments about anything to do with reliability or FMEA, please send them in, because you can see we love to talk about it.
Yep. And, it reinforces this idea of, well, this sounds like a good idea. I just need to bounce it off somebody, and yeah, we love those kind of questions, because we can bring some experience to it. We can bring some thoughts and maybe help you avoid some missteps, or maybe say, you're onto something. You need to write that up, teach others about it. We learn stuff all the time. So head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us there. Carl and I and the other hosts of the show are available through LinkedIn and through our About pages. In Carl's famous Ask Carl a Question prompts on many of his articles and content. So plenty of ways for you guys, for everybody to get in touch with us. And we really do like those comments and questions. That really helps us keep driving along with this show. No, it's a good question. One of those things that I think we actually agreed, and we didn't even, kibitz before to figure out what we were going to say.
No, we didn't. We just walked right into it.
Yeah,
that
happens.
So I'm going to go off and see if I got any other interesting questions on emails.
There you go. All right, great. We'll talk to you then soon, Carl.
Talk to you soon, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.